Hello and good day, Mike Adcock here. This is the third of a series of tutorial videos on Tropical Cyclone Reconnaissance. Today we're going to cover the Vortex Data Message, or the VDM. This is probably one of the more important messages from the reconnaissance crews. This gives you the details of the center of circulation, specifically the central pressure, the peak winds around the eye or center of circulation. So this is really probably one of the most important messages that reconnaissance crews send out. From the National Hurricane Operations Plan, VDMs are going to be sent out after they close off a circulation in an invest area. So you got a developing system. Once they determine that there is a closed circulation, that first VDM will go out, and that's kind of folks when they are tracking, following the reconnaissance missions. That's what they're looking for, is that first VDM. Okay, this is going to be upgraded to a depression or a storm or whatever the case may be. Once it is a tropical cyclone, VDMs are going to be required after each pass through the center, or each fix of the center of circulation. These messages are going to be transmitted under WMO header URNT12 KNHC for the North Atlantic, or URPN12 NHC, for the North Pacific. And of course they'll use KWBC and KBIX as alternate identifiers. Of course, you can get this information over at the National Hurricane Center website. Click on Aircraft Reconnaissance about halfway down on the left side. So today we're going to start off taking a look at a message from Hurricane Isaac in 2012. Kind of get to learn the bulletin. This is probably one of the easier bulletins to read. It is it's more straightforward than a lot of the bulletins. That's pretty cryptic with the tables and all that stuff. So this is a little, as long as you know which category, what line is what, you're pretty much set. Start off with the standard WMO header, followed by the date and time of the bulletin. Note that the bulletin will usually be about 10-15 minutes after the actual fix. And that gives the crews some time to, input all the information, make sure it's correct, get the actual splash of the drops on, all that good information. Following that's going to be the title. After that, you'll see the AL, over here. This is going to be your two-letter basin, so AL for Atlantic, EP for the Eastern Pacific, etc. The cyclone number and 4-digit year. So in this particular case, this is the 9th cyclone of the 2012 Atlantic hurricane season. Alright, now we get into the lines of the bulletin. Item Alpha, this is simply the date and time of the fix. This is going to be the flight level center fix. If you can't get the flight level center, they'll encode the surface center, but generally this is going to be your flight level fix. Item Bravo, simply the latitude and longitude of that fix. What we're trying to do is the fix. This is the flight level fix. If the surface center is fixable, then we'll put that information down if there's a significant difference from the flight level center. That is, if the surface is more than 5 nautical miles off from our flight level center, we'll put that information in the remarks section. So in that particular case, let me go back real quick. This storm was fixed at 29 degrees north, 89 degrees 55 minutes west. So, moving on to item Charlie. This is going to be our minimum height at standard level. We're going to say what level we're flying at. So in this particular case, 850 millibars or hectopascal, and then simply the height of that pressure level. So the 850 millibar level was found at 1161 meters. If we're within the lowest 1500 feet, or we're not within 1500 feet of a standard surface, this section will be omitted. Item Delta, this is going to be our estimate of the surface wind, the peak surface wind. Usually this is going to be determined from the stepped frequency microwave radiometer. If that's not available, then there's going to be a visual determination based on the wave action. So in this particular case, The step frequency microwave radiometer suggested 54 knots at the surface. Item echo, this is going to be the bearing and range from the center of the maximum surface wind. So what we're comparing here is item delta, our peak wind, to item bravo, the center fix. So in this particular case, the peak wind was 132 degrees, 60 nautical miles out from the center. So imagine you're looking at this cyclone, the peak wind was about 60 miles to the southeast of the center. Item foxtrot, this is going to be our peak flight level wind near the center. This is usually going to be the inbound leg. What we're looking at just simply a peak wind, 10-second average. So in this case, the winds were out of the southwest 224 at 72 knots. Again, don't confuse flight level winds with surface winds. There is usually a factor that you have to reduce the winds by to get surface winds. Next up is Gulf. This is the bearing and range from the center of maximum flight level winds. Again, what we're doing here is we're comparing Foxtrot, that peak flight level wind, to Bravo, the center. So in this particular case, that maximum flight level wind was located at 132 degrees, or about southeast, 65 nautical miles from the center. Next up, line H. This is probably the easiest line to read here. This is our minimum sea level pressure. In this case, 968 millibars. If a drop zone wasn't used, or the drop zone was terminated early, this would be prefixed with extrap. And then down below in the remarks section, they'll explain why that sea level pressure was extrapolated. Up next is item India. This is going to be the maximum flight level temperature and pressure altitude outside of the eye. So in this particular case, outside of the eye, the peak temperature was 17 degrees Celsius, and it was found at an altitude of 1,529 meters. On the other hand, item Juliet, same information but in the eye. So inside the eye, the temperature was 22 degrees Celsius at 1,520 meters. Now, what you're looking at is a difference between the outside peak and the inside peak. That shows you a strength. So in this particular case, you're looking at a 5 degrees Celsius, or about a 9 degrees Fahrenheit shift in temperature. You'll also notice the height difference. As you're going into the center of circulation, the lowest pressure, the aircraft is going to drop. So that accounts for that 9-meter difference. Item Kilo, this is going to be the dew point temperature and sea surface temperature inside the eye. Again, it's saturated. Our dew point is 22, which matches our eye temperature. And they were not able to get a sea surface temperature. That would usually be from a drop zone reading. Lima is going to be the character of our eye. What we're looking for is at least a 50% eye wall. Otherwise, we'll just mark it as NA. If we get a complete 100%, we'll call it a closed. We'll just say closed. Otherwise, if it's 50% or more, we'll say open, and then we'll just say what direction. So open SE for, it's open to the southeast. We can use a spiral band, kind of reporting the item Juliet with the best approximation of the shape and diameter of the inner core. If it's ragged, and like in this particular case, it's real shabby looking, we'll mark that as well. Item Mike, this is going to be the shape, orientation, and diameter. So this gets a little crazy. We'll start off though. The simple one is a circular eye, a round, perfect round eye. We'll just put C and then the diameter of that eye. So in this particular case, this was a circular eye, 40 nautical miles in diameter. CO, this is a concentric eye. You see this typically as a storm is nearing peak intensity. It's starting to go through the eye wall replacement cycles. What happens is 2 or more eye walls start to form up. So what we'll encode here, we'll say CO. We'll follow that with the smaller eye, diameter, and then the larger eye diameter. So, in this particular case, or in an example, would be CO8-14. So our inner eye is 8 miles or 8 nautical miles in diameter, followed by 14 nautical miles for the larger eye. And then the more difficult one is the elliptical one. What we're going to do here is we'll describe the major axis, that's the longest length from one end to the other. We'll explain the length of that major axis as well as the length of the minor axis. So, for instance, we'd start off with an E09 for that's our major axis. So 09 would tell us it's an east to west orientation. /15, that's the length of our major axis. So from east to west, it's 15 nautical miles across. And then another slide is with 5, for instance, and 5 is the length of our minor axis, so that's going to be north to south. After that, that's going to bring us to item November. This is going to determine, or how we determined our fix. You will always see one, penetration. You're not fixing it without penetrating. In most cases, you're going to see all 5 of these. We penetrated the eye. We penetrated with radar, with wind, with pressure, and with temperature. Like I said, almost always you'll see all 5 of these lit up. After that, you'll see that single digit off by itself. In this particular case, the number 8. This is the fix level. And in this particular case, 8 stands for 850 hectopascal. Item Oscar. This is going to be the navigation and meteorological fix accuracy. So in this particular case, alright, navigation was within 0.02. Our meteorological fix, that's going to be about half of the diameter of our light and variable winds, so within 2 nautical miles. Pretty simple and straightforward. Just kind of gives us our probability of error. And then item Papa, that's going to be the remarks section. Like all the other items, or all the other reconnaissance codes, start off with the aircraft tail number, the mission number, cyclone number, basin ID, storm name, and the observation number. Following that line is any additional remarks. You'll typically see the maximum flight level wind. May not be from this particular pass, but from this mission. Now in this particular example, I made a slight tweak, a recent change, and we're going to see if we see this this year. But rather than saying, in the past we'd say northeast quad or southeast quad, now in the National Hurricane Operations Plan, they want the bearing and range. So in this particular case, the maximum flight wind of 86 knots was found to the northeast at 5 nautical miles from the center. And that was determined at 1 hour, 49 minutes, 30 seconds Zulu. Alright, so now that we've taken a look at one, here's a new one. This is actually probably one of my most memorable reconnaissance messages. I've tweaked it up again to meet the current 2013 format. This is from Hurricane Wilma when she peaked and set the all-time record for Atlantic minimum pressure. So again, working our way through it, this message was sent at the 19th day at 8:35 Zulu. Because it was such a record-breaking storm, it took a while to verify and go through everything. This is the 24th cyclone of the 2005 Atlantic hurricane season. Alright, item A. The fix was determined on the 19th day at 8 hours, 0 minutes, 30 seconds Zulu. That position was 17 degrees north, 17 degrees 3 minutes north, 82 degrees 20 minutes west. The minimum height at 700 millibars was 2,082 meters. They were not able to estimate a minimum surface wind. The step frequency microwave radiometer wasn't able to determine it. It's nighttime, so we weren't able to grab a surface wind speed. Item E for Echo. This is the bearing and range. Well, we weren't able to determine one, so we can't get a range, so that's left blank as well. Item Foxtrot, our maximum flight level wind. So this was 320 degrees or northwest at 166 knots. Item Gulf, this is just comparing that peak wind to the center. That wind was found 221 degrees, 3 nautical miles out. So in this case, it was found southwest of the eye, 3 nautical miles out, was this report of 166 knots. Item Hotel is the minimum pressure, so in this case 884 millibars. Item I is our max temperature PA outside of the eye, so 10 degrees Celsius, so very, very cold, relatively speaking, at 3,073 meters. Conversely, in the eye, it was 14 degrees warmer, or 24 Celsius, and our height was 30 meters lower, or 3,043 meters. So very, very intense, very wrapped up hurricane, which obviously is the case. It's the strongest hurricane in the Atlantic Basin ever recorded. Item kilos, going to be the dew point and sea surface temperature. Didn't get a sea surface temperature, but the dew point was 10 Celsius. It was a closed eye. It was circular in nature, 4 nautical miles in diameter. Very, very small pinhole eye. It was determined, again, by penetration radar, wind, pressure, and temperature. And this was fixed at the 700 millibar level, based on this 7. The navigational error is 0.02, and the meteorological error is within 1 nautical mile. This was determined by aircraft tail 308. This was the 7th mission into the 24th storm of the Atlantic season, Hurricane Wilma. This is observation number 16. The peak flight level wind on this mission, 168 knots out of 135 degrees, or out of the southeast, 2 nautical miles out, and that was found at 6 hours 10 minutes 20 seconds Zulu. So hopefully, again, like I said, VDMs are relatively easy as long as you know what you're looking for. Again, most folks are looking for hotel, which is your minimum central pressure, but a lot of good information throughout there. Like I said, one of the easier bulletins to look at. Still have some more codes that we'll be looking at. Just stay tuned for that. Thank you for your time. Have a great day and take care.